Assalamualaikum and good day everyone. Welcome to CEE Webinar Series. Thank you for joining us. We have Professor John E. Mitchell with us today. He will talk about implementing change in engineering education, experience of the UCL Integrated Engineering Program. If you think that this topic is useful, please click the share button and don't forget to subscribe CEE channel. Without further ado, I would like to invite Director, Center for Engineering Education, University Technology Malaysia, Professor Dr. Khairiah Muhammad Yusof, who will be the chair for today's webinar.
Assalamualaikum, Yana. Thank you very much.
Yeah, welcome, Prof, to our virtual studio. How are you?
Fine, thank you. I hope you're well.
Okay, Prof, before we start, I think you should tell or share with us who's hosting today's webinar.
Okay, the host for today's webinar is the Faculty of Engineering, University Technology Malaysia, Academy Professor Malaysia, the Society of Engineering Education Malaysia, and of course the Center for Engineering Education, University Technology Malaysia.
Okay, talk about CEE. I think people out there want to know more about CEE. What is CEE? What is CEE do? So if you don't mind, can you share with us what is CEE actually?
Well, CEE, or the Center for Engineering Education, is a center of excellence in University Technology Malaysia. Although we were initially formed with the idea of being a center of excellence under teaching and learning, the standard or the instrument for high COE for teaching and learning has not been launched until now. So we are now classified as a center of excellence under research and innovation. We focus on innovation, on training, and also on research and engineering education. One of our main aim is to develop and support a community of practice in engineering education to, of course, enhance the quality of engineering education and education as a whole. For that reason, we work very closely with the Society of Engineering Education Malaysia, where together we form a community in Malaysia. Now you can see that CEE has a lot of collaborations all over the world as shown in the map. We've done a lot of collaborations and training throughout the world, but our focus is mainly in Asia, specifically in Malaysia. With the Society of Engineering Education Malaysia, we help to support and provide a platform and a voice for engineering educators in Malaysia. So if you're an engineering educator in Malaysia, don't forget to be one of the members of CEE. To be a member, just go to our website, www.seem.my, and sign up on the online form.
Okay, it's very interesting, and I think CEE provide a very good initiative, especially for all engineering educators in Malaysia. Okay, I think this is a time for me to pass this pitch for you, Prof, to host the webinar.
Thank you, Dr. Yana.
Okay.
So I'd like to bring on Professor John Mitchell, who's a professor in communication systems engineering in the Department of Electronics and Electrical Engineering in University College London.
Hello.
Welcome, John.
Thank
it's so
you.
Nice to
thank
have you here.
Invite. Pleasure.
So you wear several hats in UCL. You're also the Associate Dean of Education in the Faculty of Engineering Sciences. And now get this, everyone. John is the co-director of the Center for Engineering Education in UCL.
Indeed. I think like you, we thought we'd picked a unique name, but it's wonderful to find partner organisations of the same name worldwide. And It's nice that we've been able to collaborate over the last few years.
Yes, it is indeed marvelous. So, I've heard a lot about the IEP since, more than 5 years ago when I first heard you present about the IEP in Shenzhen at the Engineering Education Leaders Program conference. So, I was really impressed about the extent of what you're doing across the different engineering programs. So I would really like you, I really appreciate you sharing this with us now that you have several cohorts of graduates.
It's yes, 8 years, just over 8 years, I think, since we started the program. As you say, we've had a few graduating cohorts now. A lot of things to learn from that, and of course, in the current situation, a lot of things are changing again, and how to turn a program online of this nature is no small challenge.
Yeah. Okay, so over to you. Looking forward to learning from your experience.
Thank you very much. So thank you very much for the invite to talk to you all today. I'm going to say a little bit about the integrated engineering program that we implemented at UCL. A few things about why we did it, what it is that we've done to adjust our programs, and then spend the second half of the talk to say a little bit about how. Sadly, I'm not going to offer any sort of magic wand as to how to turn your colleagues into enthusiastic educationalists overnight, but some ideas about how to make change, particularly in a established university. So I should probably say a little bit about UCL to start. It was founded in 1826, then as the University of London. At the time in England, there were only two universities, Oxford and Cambridge. And to be admitted to either of those, you had to be a man, you had to be a member of the Church of England, and you generally had to be rich. And UCL was founded for those of any or no religion, as well as later admitting women students on equal terms with men, one of the first to do so in England. UCL is now one of the largest universities in the country in terms of academic staff, in terms of students. We're, I think, just behind Manchester and the Open University in size, and generally sits in the top 20 of many of the World League tables of universities, although that particularly measured on research. The engineering faculty was founded not long after the university was founded, and now has 10 departments covering all the aspects of engineering, mechanical, civil, electrical, chemical, some more specialist subjects, biochemical, security and crime science. And we're roughly 3,500 undergraduate students. We admit somewhere over 1,000 students a year into our engineering programs, just to give you an idea of the size of the faculty that we're talking about here. With about 1,000 staff in total, just over 300 of those are faculty staff, our academic staff. For an engineering faculty, our gender balance is now quite good. And I guess it should also be noted that roughly half of our students in the faculty come from outside the UK and the EU. We draw in students from around 131 countries from across the world. So I've often talked about the idea of needing to re-engineer engineering education. So why did we do this, and what was it that we were looking to do? A lot of talk about what engineering should be, what an engineering education should be. And when we first started this program, we were looking for something that tried to describe what it is that we felt education of an engineer should be. And I always quite like this statement. It's a sort of updating of the original Treadgold statement of that was when the Society of Civil Engineers was found in the 19th century. That engineering is the art and practice of changing the physical world for the use and benefit of all. So let me just unpick some of the things that are in that a little. So the first is that engineering is about art, something we don't often associate as our first word when we think about engineering. We often talk about science, about knowledge, about the facts and the scientific underpinnings that it's based on. But actually, I think much more we should talk about engineering as a creative subject, as one of the creative arts. At the core of engineering is developing things that didn't exist, being creative and developing innovative solutions. And I think right at the heart of trying to both change the way we view engineering and change the way students view engineering is to recast it as a creative subject. So this was a quote from a fabulous student who was on our liberal arts course, but took the engineering pathway, saying that she thinks if she would have done engineering, if she'd known what a creative subject was, she'd just taken the view that we often perpetuate of engineering is it's about solving equations, it's about the hard sums, not about the art and the creativity. So we felt that was important to capture. We also thought it was important to capture practice, that engineering is not just theory, and that many of our degrees, the practice slowly crept in as time went on over the course of our traditional programs, and that actually you have to learn a lot of theory before you can do the practical aspects of it. We felt that wasn't quite right. We felt that actually our students needed to be practicing right from the very beginning, and practicing on things that were much more than just toy projects on small labs and plugging this into that and pressing the button and writing down the answer. We needed the creative practice right from very early on in the degrees. It is important to acknowledge the connection to the physical world, that engineers do influence that world, and what engineers do is going to have an impact on the world. Now here we bring in our understanding of physics and of chemistry and biology, that we're going to have to understand those to be able to influence the world. But it's the physical world and the connection to people that are going to be very important. And again, this is something that's very much driven by our students. They wanted to see an engineering program that was really connected to the world, that had social impact, and that had an understanding of the social impact that engineers make. And so we wanted to do something that really put the engineering studies of our students and took them from being abstract and connected them to both the physical world and the people who live on it. And understanding that the decisions that engineers make, the products we build, the services we develop, even the code we write, is going to impact on people and their lives and how they operate. And that's something that should really be fundamental to our programs of study in engineering. So we wanted to grow our intake in engineering qualifications and try and bring some of the people that we didn't normally bring into engineering. People with creative backgrounds, and one of the things we did to do that was to look at our entry qualifications. In the UK, it is very typical that to go and study engineering, you need A-level subjects in maths and physics. Physics particularly was very problematic. The number of female students studying physics at schools is about 19%. So, or the proportion of female students, which is very problematic if you want to try and drive for a more gender balanced engineering program. And so across the majority of our programs, we've removed physics as an entry requirement, and that actually took quite a lot of work, quite a lot of persuasion of some of our colleagues that that could be acceptable, some accusations from externally of dumbing down, but also work to make sure that what we were missing from the physics curriculum we could make up for in our programs. And that was something that we did a lot of work on, but also found that actually wasn't as difficult as we thought it might be. So where have these demands come from? Well, I think the first one to acknowledge is that a lot of these things are demands from students. Students increasingly want to be creative, want to see how their studies in engineering address major global challenges or challenges in their own locale. They want to see the connections between theory and practice. And I think this current generation of students are particularly focused on employability. The job market, certainly up until now and probably very much into the future, is very competitive, and students seem to be more and more aware of really how the aspects of their degree are going to affect their employability, and are going to make a difference to them when they go out into the world of work. We also wanted to make sure that our students were getting the competencies they need, particularly to work with people across cultural frameworks, and to consider the global aspect of the new engineering norm, with teams working across time zones, across different cultures and in many parts of the world simultaneously. And our students are really going to need to understand that in a globally interconnected world. So students were demanding it, and we knew industry had demands. I must admit, we weren't always sure exactly what those demands were. There's been something of a procession of reports that suggest that our graduates don't necessarily have the skills that employers would like. Did sort of find that the employers aren't always necessarily articulating exactly what they want so clearly. It ranged from some, very, very, very clear requirements of teamwork and good communications and ability to work across the business, to some things that verge on the, we want graduates that will contribute to our baseline from day one. And so there is a little bit of negotiation here as to what it is that universities should be providing in terms of their graduates into the industry pool. But it's quite clear that industry was changing, the way that industry worked was changing, and that if we wanted to address some of the concerns of students for employability and their ability to work in these new work environments, we needed to do something different in our programs to support that development. So that led us to think a little bit back about what it is that is an engineering degree for, what is engineering education. And to be clear, it is education, it is not training. There are skills development elements for it, but actually that it is still a much broader and a holistic view of developing people as both learners, but as engineers. And one of the key parts to that is the development of intrinsic motivation and agency within our students. We wanted our education to really foster that enthusiasm with students, that they develop not only their technical skills, but also their professional attributes, attitudes, and competencies. We wanted students who just have in their mind from the very beginning of a project, not only the technical aspects, but also socio-economic, environmental, sustainability, as well as ethics and innovation ideas. To do this, and this is one thing that came out very early on, we needed to help students develop to be confident communicators and team workers. And this was very clear from both industry and students of things that they felt were going to really increase their employability. Some come with that more naturally, others take more time and need more support to develop those, but really critical aspects for the modern engineer. But also keep that deep specialist knowledge, which is a challenge to balance. So with those sorts of demands and thoughts in mind, it led us to think what a curriculum might look like. So we instinctively wanted something that was cross-disciplinary. The talk of global challenges, the talk of industry that didn't really fit to the disciplines anymore, made us think that we wanted our students to appreciate across different disciplines. Now, there's an interesting point here that very early on, we thought about going down a general engineering degree, thinking that, well, actually industry is no longer quite recognizing the disciplines. Should we have something that really cuts across all those disciplines? But our steer and our thinking was shaped by a number of conversations with industry, that they still wanted disciplinary specialists, but disciplinary specialists that inherently knew how to work with other disciplines, so they weren't siloed, they weren't just knowledge in their own discipline, but they still needed that technical depth. And so we developed a curriculum of project and problem-based learning, so increased amounts of group learning and group assessment. And where possible, we wanted to try and bring in authentic problems, things that really mirrored problems that industry was facing, things that were live problems, that were real situations. Interestingly, some of our research work suggests that actually authentic is a difficult word in this sense, that what really resonates with students are problems that they feel are authentic. It doesn't matter quite so much whether they actually are authentic or not. And some of the most authentic problems we've had have had pushback from students who don't believe they are really what would go on in the world of work, which is quite an interesting nuance to what an authentic problem should be. for all of these, we wanted it to be research-based and inquiry-based, and very much evidence of linking to the research that UCL does. We are, as I say, a global top 20 university that is that reputation is built on its research, and our students come to us because of our research prowess and research achievements. And so we really wanted to tie a curriculum to the research strengths that we had within the faculty. So we hopefully used education research, industry engagement, as well as talking to our students about what they wanted it to be. And the result, after just over 18 months of development, was what we call the Integrated Engineering Programme. So I'll take a few moments to say a little bit about what that looks like. So what we wanted was something that provided connection activities across the different disciplines. So in reality, a lot of the disciplinary knowledge just stayed the same. There's been some changes in the way that some of it is delivered, but much of the core of the disciplines stays as it was before. But we now have activities that allow our students in different disciplines to connect, to engage with other students. And we thought about whether we do that at, there were suggestions at the beginning, could we have joint thermodynamics classes? Could we all have everyone learn something about structures, and would that help? And when we looked at that, what we actually found is, although the majority of engineering degrees teach thermodynamics in some form and use much of the same language on the syllabus, the context they place it in and how they talk about it is very different between the way an electrical engineer addresses thermodynamics as a chemical engineering student perhaps addresses thermodynamics. And that didn't feel the right place to make these connections. Where it did feel right, and where students really seemed to come together and share, but also bring their expertise, was in projects. And so this is predominantly where we connect our students together, when they're actually taking on these real, practical, authentic projects. So we now have a common curriculum structure, although not necessarily a common curriculum, that promotes practical applications and the development of transferable skills, alongside the fundamental technical knowledge. And unlike certainly some of the developments that I discovered later on, particularly some well-known US curriculum revision, we took the bold decision, shall we say, to make this for everyone. We decided that if we felt this was the way that we should teach our students, we should change all of our programs. And so we made a step change. 2014, we went from just over 800 students that entered the faculty at that point. From one program, we changed to the new program as a step change between programs. A lot of people thought that was a little bit mad, and that we should start a new program and attract students to it and gradually change it over time. But we took the decision that that was a very safe way of doing it, but also would have taken a very long time to achieve. And we felt we should make more of a step change. So these are some of our aims, and I think I've talked to many of these. But what I will step onto is a diagram. So this is how our degrees looked. I think it's fair to say they were very individual to each department. There wasn't a lot of collaboration between many of the departments. Some between biochemical and chemical. Management science taught some service teaching, some project management and other things into a number of the degrees. But other than that, they were fairly siloed degrees. I always like the term from Daniel Hastings of MIT, who talked about cylinders of excellence, but I think that might be slightly too kind to it. And so we had these very individual departments with very individual degree programs. And so what the IEP does is bring in a number of activities where the departments can connect together. So in the first year, we have engineering challenges. So the very first day of the very first week of term, our students are put in teams, some interdisciplinary teams, and given a problem to solve. Now, this was quite an interesting one for many staff who claimed, but our students, we've not taught them anything yet. How can they be given a project to do? They're not engineers. We haven't taught them anything. And while there's a little bit of truth to that, it's also true that they're not blank sheets of paper. They bring skills, they bring knowledge. And this is really a process of trying to introduce the the structure of doing a project. It's not something where we're actually that worried about the outcomes, certainly not the products that the outputs that they make. It's much more about introducing the students to the process. And so here we get our first real introduction to teamwork skills, communication skills, the design cycle of being an engineer, the processes of an engineering project. And these projects typically focus on the user, on understanding the requirements. And so that's a key starting point. Alongside that, we also have a thread of design and professional skills. And this is where the students look at some of those aspects about teamwork, but in smaller workshop groups. And this is something that we felt that was really quite important. We'd done teamwork before, we'd done project-based learning, problem-based learning activities in teams. But what we discovered was that actually just by putting students in teams doesn't mean that they necessarily developed skills in teamwork, and certainly didn't develop necessarily good skills in teamwork. And so we felt that actually we needed to scaffold that project work with something that really enhanced the skills of our students and enabled them to do better in their studies, and to ensure that what they're doing was grounded in developing those skills appropriately. The one subject that we did decide all students should learn together was mathematical modelling and analysis. And so this took a fairly traditional maths course taught by the maths department and turned it into an engineering specific one with real emphasis on the modelling and analysis. So it's taught very much connected to MATLAB as a tool, and very much as mathematics as a tool in the engineer's armory to be able to develop models and understand the processes that they are developing. Probably the major thing that the curriculum is known for are the scenarios. And so I should explain a little bit about how they work. They are 1 week projects. And so our curriculum is structured around, after the first term, 4 weeks of instruction, and then a 1 week project. And this repeats over and over through the first and second year of the curriculum. And so this is where students get a chance to actually develop their skills and take the theoretical knowledge that they've learnt in the 4 weeks, which in many cases is similar to the delivery that was before the change, but they're using that knowledge in a 1 week design project, all done in teams and with milestones and scaffolded, usually with a presentation or some sort of authentic assessment at the end of that week. The other innovation was minors. This is something we'd never had before. And so here, this was a lot of the students liked the idea of being able to choose from a wide range of subjects outside of their discipline, but also found that picking things a little bit at random. And so we decided that what we would like to do is, rather than having individual electives, to have a thread of electives. So it's 3 modules that go over 2 years, in disciplines, in subjects that are either multidisciplinary, interdisciplinary subjects, or completely outside of disciplines. So students can take on languages, can take on finance, can take on entrepreneurship, things that cut across the disciplines. And all our students, all 800, choose one from what is now a list of about 20 minors that they can take. And then the final, I guess, large element of the IEP is a program that we called How to Change the World. And so this is our sort of capstone of the first 2 years, a 2 week project-based learning activity where students will take on a challenge that is is aligned to one of the UN sustainability goals. The minors continue in the 3rd year, and also more and more we're increasing the number of interdisciplinary projects that link departments that our students do as their major capstone in their discipline. So we often draw it out like this, but another way of thinking about it is to think about we often draw the structure like this, although I do remind my colleague who drew this that it's not a good engineering diagram. It's not to scale, as the discipline, the technical aspect, is actually still about 80%. But we like to think of the IEP as this thread of projects connecting the discipline, connecting the maths, connecting the professional skills to this repeated cycle of projects that students take on. And so they learn some theory, and then they get an opportunity to put it into practice alongside practicing their teamwork, considering sustainability, considering ethics in projects that span right away across the first 2 years, and hopefully build up to enhancing the third year project at the end. So what sort of things go on? Well, what has changed? You'll see a lot more teamwork, a lot more activity in small groups, and a lot more design in the early years. And again, design is a word where many departments said, we do design, we get them to design a cog. So actually, this is design writ large, so design that has real consideration for users, real consideration for production, for manufacture, right the way through the design cycle. So design in the broadest sense of the word. To give you an example, we have one of the challenges. So this is in the second 5 weeks of the first year. Students are given a challenge to produce a miniature vaccine production facility for sub-Saharan Africa. Now, this is actually based out of research work of a colleague who looks at vaccines, that the difficulty in shipping vaccines and whether local production would be more appropriate. And so our chemical engineers, biochemical engineers and medical physicists look at the vaccine itself and how you produce it, the fermenting vessel. Our mechanical and civil engineers look at the plant that's needed, the water purification to deliver such a system. And the computer scientists and electrical engineers look at the control systems, look for stirring, for heating. And the idea is that they're all consultant engineers trying to doing individual subsystems of a larger plant. And so this is one project, but is 800 students, 128 teams this year, broken down into a number of sub teams across the piece. The scenarios often end in a competition, and this is an example. This is one from the IMEC challenge. And again, these are things where often there's a requirement to make and build. So here it's a device that can climb the pole carrying a chain. And there is a demonstration, an end point to many of these 1 week projects. And so we've really taken on, and like this quote from Ove Arup about total design, about bringing the professions together from the start. And probably where this really comes together is at the end of the second year. So after the exams, we run a program called How to Change the World. It's a very bold title. It's not one that I was necessarily keen on, but has really gained some traction, particularly as we saw students coming back saying, you know, I did How to Change the World on my CV. And it was the first thing people asked me about when I went for the interview. And I told them it was teamwork. It looked at sustainability challenges. It required us to consider diverse users, and really finding that interviewers were seeing this as really something very positive. So the idea is we take both developing world and developed world problems and address them in the context of the UN sustainability goals. So you take clean water and sanitation, for example. One cohort was looking at sanitation in a Jordanian refugee camp. One team was looking at pollution in the Thames River in London. And so we look at these sustainability goals through a number of different lenses, really requiring the students to think about who the users are, in partnership with generally non-governmental organisations, but also having industry in to come and advise the students through the process as to whether these projects are appropriate, can they be made, do they think they could be funded and developed. So that was some of our thinking behind why we chose the IEP and what it was. Perhaps now's a good time to take a moment and see if there are any questions.
Rama. Okay, that was nice, John. Okay,
Thank you.
we'll see if there's any comments. Okay, there's one comment: how to change the world. That's really impressive because it's really big. It's a big statement.
It is. I mean, and I was never that keen on the word. I thought it was too grand, but it's interesting. What we use it for to explain to students is that you know, you could think of it as something slightly missionary, go out there and change the world, but actually it's more the reverse. It's that, you know, engineers need to understand that whether they like it or not, we change people's lives, we change the world, whether it's the device we develop, the product we make, the code we write, the system. You know, one of the groups I always find this hardest to get over to are computer scientists who think, well, I just write code. It's like, you know, how has Facebook changed the world? How has, you know, these platforms have made huge social change, in many cases without understanding necessarily what the impact of that social change is and how influential they are. And I think we need to be mindful with our students that, you know, actually, you know, engineering brings great power. You know, if a successful engineer has a real impact on lives, and to actually understand and be constructive in that impact is very important, even though, you know, it might not be obvious that that's actually what you're going to be doing when you're developing products, and that we all have a responsibility, however small a part of a much bigger team as we often are in engineering projects. We have to ensure that we're asking the right questions to make sure that the things that we develop are socially responsible, are equitable.
That is true, because we have lasting impact. Okay, that's one question here, John. Are the challenge projects offered as standalone module?
So the two challenges that students take as their projects when they first join us are a module in itself. So that is a standalone module, and that was done very specifically because we wanted that to be something where the students could explore being as part of a project team. The scenarios are generally all embedded in in the design and professional skills in a larger module that has the skills development separately throughout the rest of the term. So they are tended to be separate. Again, it's one of the issues and one of the reasons for doing the scenario was sort of to push back at modularization. You know, engineering is not an encyclopedic subject. It's not about you learn this thing, you learn that thing, you learn that thing. Actually, where the quality of engineering comes is, yes, knowing those things, but how they connect together and how you build something, taking your circuit theory and your thermodynamics and your electromagnetics, and it's knowing the connections. And I think what we'd seen, and one of the reasons for doing this, was that students, we've put things in boxes for good administrative reasons, but students were learning them in boxes. I've done the exam on that, I don't need to remember it. And actually we needed to encourage students to say, actually, no, you need to take a bit of that and a bit of that and a bit of that, and combining all these knowledges where design comes, where the engineering skill comes.
It's about the synthesis of the knowledge.
Exactly.
So that's another question here from Dr. Yati Melon from UTP. How actually do students learn? You know, if there's anything that they don't know, are they, you know, do you go do the supervisors guide them, or is it through an inquiry based learning or something?
So they have, it's a combination of things. So we design the scenarios and the challenges so that the core material we think that students need to know is taught alongside or beforehand in the case of the scenarios. So the learning is very much structured towards that project, so that we believe the students have the core. However, what we found, and it's one of the biggest issues I find with problem-based learning and project-based learning, is you find the students always learn good stuff. You can't always quite determine what that's going to be. And the more you say, if you start with trying to design a problem and saying students need to learn this, this, and this, invariably the problem gets a bit boring. It gets very constricted by, you know, if everyone's got to learn the same thing. And so there is a lot of inquiry-based learning. There is a lot of support. You know, we have a lot of postgraduate teaching assistants and staff who sit with the groups and will help them to develop other bits of knowledge that they want. And we see students going off and doing all sorts of wonderful things and finding bits of knowledge that we didn't know about to augment their projects. And again, I think that's part of the joy of it. I mean, it's interesting. It's the concern I always have over if you try and go to a fully problem-based learning curriculum, you know, the issues with accreditation of ensuring students meet all these steps. It's actually very hard to have interesting and authentic problems that also hit all the steps. It's a challenge to really do that.
So I think this is the last question we'll take for now. Is there any compromise between learning the fundamentals and heading directly to the challenges without, are there any instances where they are actually ill-prepared for the challenges?
I mean, inevitably they are ill prepared for the challenges. This is, and in part that is part of the point, because and this has to be done quite carefully. It's as much to explore with the students what they will need to know to deal with the challenges as much as being able to deal with it. So I think, yes, it is something that is a fundamental shift. I mean, we've often believed that you need to teach years and years in theory before you can let students loose on a project. This has been a traditional view of engineering since the 19th century. But actually, the alternative has a very different approach, but creates some interesting outcomes where the students are exploring the problem at a higher level and understanding what it is that the knowledge that they are learning. And so again, it's about connecting the knowledge back to the problem. And again, we feel that this is part of the theory of, giving some of that self-efficacy to students. So rather than continually telling a student this theory will be useful, but not until your third or fourth year of study, actually it's like, well, you were looking at that problem. Remember when you couldn't work out what you needed to do this? Well, this is how it will. This is what you're going to need.
Yeah, that's true. So it's actually also motivating them to go further, right?
That's the hope. I mean, one of the things we've always wanted to do, and we've never quite found the way to do it in the curriculum, is take the project that they do right at the beginning and do it again 2 or 3 years down the line. And say, we asked you this, and you really, you struggled. You worked out what needed to be done, but you couldn't do it. Now, can you do it?
Okay, so before we continue and look at the change process that you have gone through, we'll like to know the perception of our audience on the word change. We're going to change the world, and then you went through this change process in the curriculum. Can we look at the Mentimeter, Dr. Kamaruddin? Okay, everyone in the audience, please go to www.menti.com and use the code 155173. I can see that some of our audience have already gone in. They are really advanced. So please go and type in 3 words that you think of when you hear the word change. Okay, we're giving you 1 minute to do this, yeah? Transform is so far the biggest. Okay, if you look at this, transform has consistently, yeah, so that means the highest vote goes to transform. Challenge is also doing well. And we do have a positive audience because better is also quite big. Innovation, disruption, resistance. Okay, revolution. So we'd like to hear more from you. Do you see all these words inside when you're doing the change process?
Certainly.
Okay, over to you. Yeah.
Thank you. I think, yeah, I mean, transform is interesting. There is a balance between how much transformation needs to be revolution and how much it can be pockets of revolution and pockets of evolution. I think for me, you know, starting from an institution that was traditional, that had, you know, by most of its measures, successful. You know, our students, we got plenty of students. We weren't having trouble recruiting. The majority of them got a good degree. The majority went on to good jobs. So, you know, by the standard metrics that we usually like to measure universities by, we were doing well. There was no real problem. But that makes it difficult to make a case necessarily for radical transformation. But we needed to do enough that something felt really different. And again, I think there's fine lines of, you know, we'd seen in the past little pockets of innovation, some really nice problem-based learning modules here, there, and everywhere. But we really saw that it was very hard for those to get further traction. There needed to be something that shook everything up, threw the bits up in the air. Now, the fact is, you know, if I'm completely honest, the majority of the bits landed back exactly where they were before, but enough of them changed to make the program feel very different, I think, and to give our students a different experience by the way we linked some of what are the traditional elements that stayed the same with other elements of the program. So I'll give you a little bit of the sort of the background and some of the challenges. And I've been to many of these talks about transformation where someone has stood up and sort of talked about how wonderful they are and how easy it was, and, you know, all the staff thought this was wonderful and got on board. And no, it's not like that. It really wasn't. It isn't like that. And you know, quite frankly, I think if there isn't resistance, you're probably not trying to do enough. So the history of this came about my new dean to the faculty, very enthusiastic, making lots of changes. Went to a global engineering deans convention, I think it was, and got very enthused by a lot of the radical changes in engineering. I think spoke with Rick Miller from Olin and some other people at Chicago, and came back and really wanted to do something different. He'd done some knew about problem and project-based learning, wanted to shake things up. And as he did, he wrote one Sunday afternoon, he wrote an email to all staff in the faculty saying, we're going to change the way we teach. And he thought it would be very helpful if he included an example of what this might look like. And so he sketched this out. He was a systems engineer, and he sketched this out of what a new curriculum might look like, and called it a straw man. Everyone hated it. Everyone looked at it and filled in the gaps that weren't there and decided that this really couldn't work for them. He now talks about the fact that this created debate. It certainly did that, and this was really the starting point of the program. And so after about 4 months of discussion about where we would go, I was brought in. There was an open call for someone to lead this, and I thought it would be interesting. So I stepped forward to try and lead this process. The first thing that really discovered was to try and get an understanding of what was in the programs, and to really try and shock people and get people to think about what was their curriculum. And now the interesting thing I discovered was that actually a lot of the people who teach in the departments really don't have a full picture of what the program looks like. They understand their part, their specialist area, perhaps within a degree, but often it's very few people who understand everything we teach. And so there was a question about, you know, the fundamentals and how the fundamentals relate to making space. Actually, we found that there was probably more space in the curriculum than we thought there was. There were a lot of things that we weren't quite clear why we still taught. There were a lot of things where there was overlap. And lots of potential for rationalization. So this was an exercise I would do with staff. We'd bring in a key set of people within a department, and I'd mapped out on these large post-it notes everything that was in their curriculum in the first 2 years. And many were shocked by all the knowledge that we forced into the curriculum, and also quite shocked by the fact that actually development of skills wasn't really ever talked about in the curriculum at all, certainly not in the early years. And it was very, very knowledge-based and science-based. And I think laying it out in that way. I used to pin these up on a wall of an office we had, and just to get people an impression of the scale of what it is that we taught was really quite a good starting point to understand the program as a whole, rather than as the program as subsets of modules or collections of modules. It did, however, always bring in a set of difficult conversations. When you looked at the programs and saw, all this good stuff of background physics and chemistry and mathematics, all the things that make up the core of engineering, you do have to have the conversation of, something's got to make some room. If we want to try and add new things to the curriculum, to writing, experimental methods, innovation, we've got to make some room in the curriculum, and we've got to challenge those things that we insistently say are fundamentals, but are they really still fundamentals for our students today? And think about how we might challenge that to make room for the other things we want our students to develop, but also for the practical aspects, for the making and building projects. We need to find a little bit of a time within our curriculum for that. And that was a big challenge of those debates and negotiations about what is still fundamental. Interestingly, and this is an exercise you can try in your own institutions, try and get a group of academics to agree on what the fundamentals of their discipline actually are. It's a very interesting debate to have. Some may argue that if you can't agree on what the fundamentals are they really fundamentals. So we had lots of very interesting conversations in that. So what would be my tips for how change is achieved? Well, I think the first thing I would suggest is you do need to talk to lots of people. I'd been in my own department of electronic engineering. I'd understood some, new people from other departments, but I always imagined the other departments thought a bit like us and saw the degree like us. I'd never quite appreciated how different the disciplines were. Now, sometimes that's because of the discipline itself, others it's just historical of that particular department. But I think I just certainly assumed that there was a lot of homogeneity of thought across the different departments, and realized that actually there wasn't. The things that concerned people about their curriculum, the things that they valued most, actually varied from group to group, depending on their background, from discipline to discipline, department to department. And understanding that is really key to making progress. And that actually I did feel a little guilty at times of having I had a set of slides for each department. And that wasn't that they said anything different. I wasn't telling different stories to different departments, but actually the emphasis I placed on things was subtly different between the different departments, because their concerns, the things that they worried about, the things that they held dear within their own curriculum were different and needed to be talked about in a slightly different way. So I spent a lot of time taking people for coffee, trying to understand what it is that were their concerns, what it is that they needed. The other part of this is also understanding about talking to people in the centre. There's a lot of the structures of universities, certainly in my experience, seem to be developed purely to ensure that things don't change without due process and without due consideration. And particularly when you're looking to do something a bit different, a bit radical, it doesn't necessarily always fit with the view of the university. However, the thing that I think was most encouraging was that I never found that there was anyone who said no. They often suggested different ways of doing it, but having those conversations and not just putting ideas on the form and giving it out to people, but actually discussing, sitting in a room and talking through. And the same happened with our accreditation, who were incredibly supportive when they understood what they wanted to do. But you do have to be careful what it is that you actually, who you talk to and what you see. My faculty tutor, just before he retired, actually did honestly give me a list of people I needed to talk to, people I shouldn't bother talking to, and those that needed to be felt to be in the process, but I really shouldn't listen to them because they will say you shouldn't be doing this. And understanding those dynamics within the organisation is quite important. in that there will be voices to stifle change, and many of the same things came up time and time again. Accreditation won't allow that, was something I heard many times. Well, we got the accreditors in very early on and said, this is what we're planning and how do we go about it. And they were very supportive. They liked the idea, but also gave us very positive tips about things we should look out for. Regulations, again, regulations are always written for the norm, and if you're trying to stretch some of those boundaries, but again, it's time to engage. If you can engage with people who are behind the regulations, actually invariably they will see it for what it is, of someone trying to do something innovative and for the benefit of students. And I think as long as you make the case in those terms, I've certainly found that even regulators will engage with you on that. You won't get staff to do it. Well, actually, we found that there was a sufficient pool of staff that would engage, and there were enough. We didn't have to bring every member of staff with us to begin with, and that was, I think, part of the pragmatic nature of this, that we didn't need all in staff to engage. It will take years. Well, it will take, I think these sorts of things take as long as you allow it. We set ourselves a very ambitious time frame. I think one thing I was very conscious of is you need to make submissions. We had a lot of support from some new heads of department, a new dean, a new provost. There was a lot of things came together at the same time, and that created quite an opportunity, which means you have to deliver within the lifetime. Fortunately, the dean that has replaced the one that originally started this has been very positive and is very supportive of the program, but that wasn't necessarily always going to be the case. And so you need to form an impetus to deliver in what seems like a very short time frame. But I think experience has shown me, at least, that the longer that you have, the more time you will talk about it before you rush to finish off a job that should have been started earlier. It still doesn't necessarily mean you take much longer. So what do you need to make change happen? Well, I go back to some very basic principles. Fear. Now, this isn't necessarily the fear of a crisis, the fear that things are going hugely wrong, although that can help to make a change. But you need enough staff that have a fear that they're not doing well enough for their students, that they need to make a change. And we certainly found across departments there were large enough pockets of enthusiastic staff that would engage in the process. Doesn't need to be everyone, doesn't need to be necessarily universal, and I think in all honesty will never be, but enough staff that will engage and will get the process moving and really be enthusiasts and champions for a change. Fear and surprise, and this is an interesting one because it goes against a lot of the theories of how you deliver change, of being very transparent. I think there are opportunities to be transparent, but equally, I think you need to measure that with actually listening, consulting, but also spending sufficient time developing your case to something that is firm. I think certainly in the early part of the program, we were consulting and showing our ideas to people very, very regularly, and that really just ended up being flooded with lots of opposing and difficult to square ideas at the time. And where progress really came was when we took those ideas and a small group of us went away and actually didn't really put anything out there for a couple of months while we really firmed up based on those ideas. And by the time we went back, it was in such a position that it was very well formed, but equally we'd done enough listening that people were able to see their concerns reflected in what it was we'd done to address them, and seen their desires and the things that they wanted in it. And so that balance between how often you're consulting and how you make progress, I think is one that's very important to strike. You do need leadership. You do need support from the highest levels. You do need staff who believe that there is a will for this to happen, and that You know, UCL is certainly not an institution where, by any means, where if the dean says everyone jumps and it happens, but have clear leadership of the direction. There will be challenges. There will be many who certainly won't do it just because the dean says that it should happen, or the senior leadership. But they do set a culture. They do set a direction. And so the drive of the dean and strong leadership is absolutely important. And for us, the final one was, this is a bit of a joke, because we were known for having this, as you can see from my slides, this sort of orange and grey branding. And this was actually important in a turning point for us, that probably if we go back 10, 12 years, the departments were the strongest elements. And so they really were very much autonomous units. And around that time, we started with executive deans and the faculty, engineering as an entity becoming much stronger. And so in a way, this was very much in line with that. And I think if this had been tried 5 or 10 years earlier, it would have been very difficult, because the departments were very much the center of power. And we had to, as part of this process, build a narrative that the engineering faculty as a collective could be much more powerful if the departments came together. And so this was part of a broader change in that sense, that we could support departments, and there was benefit of the departments of being in this collective that we called the Faculty of Engineering, which was something that was only relatively, in the timescales of university development, a relatively recent step. And so the fact that engineering and UCL engineering, the branding, we changed the world, was something that was a really strong driver for departments to come together and seeing a benefit of coming together. And so I think what I would advise people is to think of the structures you were operating in. It's not just so easy to say we should come together. You have to have some structural, and in our case it was financial structures and staffing structures that really meant that there was benefit of us coming together as a faculty, and departments joining forces in some of these activities. And that was really important to the development. The structures and the context you have is very important. So if I can just sort of comment on a few things that we found that were really important to be able to deliver this. As much as we wanted this to be research-based and evidence-based, what I'd seen struggle in a few other institutions was where people come back with wonderful ideas. They go to Olin, and Olin is a brilliant place. It's inspirational, but Olin is a small campus-based university outskirts of Boston, takes in 65 students a year, has the classrooms where every module can have its own class for design. Contrast that with UCL, 1,000 students a year, 10 departments, very space constrained. We're probably in some of the most expensive real estate on the planet, in the West End of London. There were very different constraints, and so bringing back really innovative ideas and trying to sell them to staff is incredibly difficult. And you can always claim with hindsight, I'm not sure I ever articulated this as a design, but it's what happened, was pretty much everything that succeeded in being implemented, someone was doing somewhere at UCL. The problem-based learning, the scenarios, the project-based learning, the emphasis on skills, not necessarily in engineering, not necessarily on any sort of scale. A lot we had to work out how we scaled up. But it was really important that you could take members of staff to go and see the thing that you were talking about. And it was often the turning point in the conversations where you went from someone not really understanding, they sort of got the idea that students do these week-long projects, but didn't really understand quite what it meant. As soon as you can take those members of staff and particularly connect them with the students, embed them, take them for an afternoon, get them talking to the students, get them seeing what it is that the students are getting out of these projects, the conversation just changed. And they came back enthusiastic. They said, "Oh, now I see. I could do this. I could do." That was when we got the shift and got people who were, these are still at the enthusiastic end. They were willing to be involved. They were keen on doing something, but just couldn't quite get what it is that it was. if you can take them, they can see it, they can engage with it, and particularly, you know, ideally if it's within the own institution, so they can't say, well, that will never work here. There's a real power to that. So look at your local precedent, look what people are doing, look at the good practice, and engage your colleagues with it. And you do really need to remember the students. We talked a lot, and a lot of the questions I get asked in these talks about, you know, staff are conservative, they don't like change. Remember that as much as when students will articulate some of the things that make you think they want a curriculum like this, they are also conservative. You know, we get top students at UCL, and one of the reasons they're top students is that they've learned to play the games that we set them. They're very good at exams. They're very good at the types of assessment we have. They're very good at playing the games that the traditional schooling structure has taught them to play. And a program like this, that's very project-based, very authentic in its assessment, is outside their comfort zone. It changes what they expect. It pushes them in ways that they didn't expect. As much as they say they wanted something slightly different, isn't the way they expected. And, you know, these quotes here are some of the things I heard within the first 5 weeks. You know, doing team working and writing, useless skills for an engineer. I came for science and hard sums. This is what I should be doing. And so, you know, there's always going to be a proportion of students that will find that transition difficult and will be very vocal about it. But they do get to understand it. It takes some a little longer than others. It takes time for them to appreciate it. You know, some get it immediately, and some it takes longer. I'm sure there's a few who never quite get that this is what they were. This is why we were doing this. But interestingly, I had, you know, remember a student who'd been very vocal in the first 5 weeks in one of the first cohorts. I bumped into in the lift, starting their 3rd year, and they were saying, you know, I went for a job interview and I thought they would ask me technical questions, ask me, you know, to solve equations, but they asked me about teamwork and when I'd had to, you know, work with difficult people and when I'd had to plan, and you know, I just talked about the IEP modules. You know, maybe there is something in it after all. And so, you know, sometimes you have to take these small wins of the students. The other thing this was a diagram, a version I've stolen for version from Jessica Townsend at Olin and Alison Goodwin from Purdue. But we often talk a lot about the pedagogy, the curriculum, and this is one thing that we spend a lot of time shaping in these discussions, and rightly so. But I really come to appreciate how both the culture and the environment that you put students in, and I mean environment, both the physical environment, but also the cultural environment you put them in, really impacts on how you can develop. And those two things really need to be developed in parallel. I think for us, we spent a lot of time on the pedagogy and curriculum, and we knew culture would be important. I think we didn't pay enough attention to the environment, to the types of spaces we use, to the types of facilities we give students to do this sort of work, and that has been a challenge early on. And so rethinking the spaces and the environment plays such a huge impact on the way that students engage in activities. I think it's something that really needs to be considered as part of any change program. So a few last things I will leave you with. One, when I first started this and sort of thought change was this linear process, the thing I discovered really is that actually change is not a linear process. It's very hard to get it going. And it's also very hard to restart. A lot of my colleagues have told me many times that this was once in a generation and don't come back asking us to change again anytime soon. Which all that taught me was we need to do it now. If you want to make the big changes, don't think there'll be a phase 2 and come back. Once you've got the momentum, make sure you have a clear picture of the things that you really want to change. There'll be other things that you'd like to change, and you will lose those battles and don't necessarily get everything changed that you want. But make sure you have a clear picture of the things you want to change and push for them while you've got the momentum, because it's very hard to restart the momentum once you've made that change. It's very hard to start in the first place, but once you've got it going, there's an opportunity to push harder. And in that, the cultural change. I think the faculty coming together. The IEP is now an advocate for departments, and it's seen as something that brings departments together and adds value to all the departments. And that's something I never necessarily wasn't in my planning at the beginning. I sort of thought that this would be a process of change and then it would be the new normal and we would fall back to that. But actually the bringing together of people is a real value, and the fact that a lot of the long-term value we've seen was in the discussion, in the bringing together groups of people to have those discussions early on, and that is really, really influential. And make sure you think about the continuity. Change, particularly, there is an inertia, there is a gravity for change to sort of fall back to old norms unless you keep some pressure to keep things, particularly as staff change, as people forget why you did this in the first place. There is a sort of a pull back to the gravity center of the traditional, and so to do that, to make sure you can continue, is very important. And think of all the other wonderful things that came out of it. So the Centre for Engineering and Education really grew out of the IEP as a way of trying to help others doing similar things, to collaborate with others. I often call it the propaganda arm of the IEP, but to really engage with the community. And there's a fabulous community, other centres for engineering education across the globe, as well as many others, that it's really worthwhile to engage with and to get their experience and expertise. So thank you all very much for your attention, and I hope you found that useful, and I'm happy to take any questions.
That was really wonderful. I learned a lot from your sharing. Thank you very much. We have a lot of questions. Interesting ones. Can we have the questions, Dr. Kamaruddin? There's one question that I saw earlier. When you're talking about having the IEP, is there any change also on the way the faculty members teach in the classes? Does this spill over to the classes?
It has done. I think, as I mentioned earlier, we were trying to be quite pragmatic about this. One of the things we didn't want to do was try and force all faculty members to teach in a problem-based learning style. I don't think having everything problem-based learning is necessarily such a good idea, but also pushing someone to teach in a style that they didn't feel comfortable in was not something we wanted to do. What we've seen is that there were, because of it was a reasonable shake-up, all staff had to rethink their modules and how they connected to things. And a number took the opportunity to redevelop the way they taught in their classroom. To be fair to them, a number didn't. A number continued in their traditional sense, but have started to modify as we've reached a critical mass and have seen other things. But I think it was important to be able to allow those to happen. And actually, there's gradual pressure on them to change from the students, but also, actually within a curriculum that has quite a lot of problem-based learning, students find a traditional old-style lecture actually quite therapeutic in some ways. It's quite refreshing because it's not the main anymore. It's not the norm. So actually, I think that balanced curriculum works much better, and the fact that there are people still, I think we just about lost acetates, but still, whiteboards and talking to slides. Actually, that in a balanced curriculum is not so much of an issue. It's only when that is the dominant form of pedagogy. So I think one of the things that was necessary, but also has worked well of this, is that you can have a balance of things. But it is interesting to see, I think people have written about the fact that there isn't a diffusion of best practice necessarily. That just because one person does things, it rarely means that lots of people pick it up. But I do think there is a threshold to that. And if you can change enough and people can see that it's a significant part, and they start feeling pressure to up their game. And certainly we've worked very hard, and it seems to be paying off, of developing this culture that says an emphasis of teaching is appropriate, and that all staff need to, it is no good just to teach. You have to teach well and be seen to teach well. I have serious issues with some of the student evaluation and the whole process of doing that. But in other terms, that you put an effort into teaching and trying to build that culture, that it will be rewarded, that it is valued, and that is something that I think you've also been involved in promotions, and really ensuring that now, we have a line that it's, it is no longer acceptable to get promotion, even on a research track, by just saying, well, I've taught some modules. We want evidence that you have actually thought about those modules and that you are actively engaged in thinking about your teaching, and that is evidence that we are asking everyone to provide in their promotion cases. And that's made a huge difference, that it's put teaching on the agenda of so many meetings that it was just absent from.
Wow, that is really impressive. So teaching is a priority now. That sends the signal that because you will be assessed on the teaching aspects.
Yeah, I mean, I'm almost slightly cautious because there are huge biases in student evaluation surveys, and they're quite problematic. There's lots of research that demonstrates, as a white man, I'm half a percentage point up on female colleagues, for example, and things. These things we really shouldn't be making very really structured decisions on. But equally, I think it's more about that. It's more about evidence of engaging with the teaching. So I think we're trying to be careful of not using very crude metrics for engagement, but actually evidence of engagement in the teaching and evidence of thinking, and that's more challenging.
Okay, there's a question here on disruptions. So what's your advice on dealing with the disruptions or chaos when implementing change to an otherwise harmonious system?
Yes. Obviously, a question from a control engineer potentially. One of my very good colleagues who was leading a lot of this is also a control engineer, and he often talked about bang control theory, that the shortest path between two states is
Totally open or totally closed.
and he's right. The other point that he also points out is the danger with bang control is things oscillate. And that's quite a good analogy. You have to be very reactive in the first, when you make such a control, such a change. We looked at it in many ways, and actually I think disruption is necessary, and it can be good. I think we I saw certainly some programs where they tried to do things incrementally, and particularly when you're building a program like this, the whole point of it was the interrelated nature of it. And so you change one bit, it doesn't work well. Well, why doesn't it work well? Is it because there's something wrong with it, or actually the bits that was aiming to support it are not quite there yet? And so I think we looked at many aspects and decided that a step change was really appropriate, but you do need to listen to staff, listen to students, be prepared to be quite reactive, and to mitigate for the oscillations and damp those oscillations quite rapidly, because they will happen when you do that sort of control shift.
So you have to be open to the comments and the feedback that you're getting.
I mean, and it was interesting. I remember colleagues saying, well, we've never had feedback like this from first years before. It's like, we never talked to first years before. We never got feedback from first years. This is in the first 5 weeks. This was, whereas in this program, we spent a lot of time, particularly in the early stages, really engaging with the student cohort, really talking to them. And there was a shock. As I said, we pushed them outside their comfort zone. And, when you're outside your comfort zone, you are by definition uncomfortable, and that's not. It's a necessary place to be, but not always. Uncomfortable students are noisy, and we found that.
So
but actually, if you engage with them and talk to them, it was a very productive conversation.
Okay. There's a question here from Professor Zainuddin, our Deputy Vice Chancellor for Academic. He says, how have you been coping, and what are the challenges, and what are among the adjustments that you had to make with regards to the IEP projects now that we have to switch to emergency remote teaching?
Yeah, I mean, we were fortunate we didn't go into lockdown until most of the projects had been finished. So How to Change the World didn't run this year. It was just before the How to Change the World was supposed to happen. And so we felt we couldn't adjust that. And with all the other pressures that students were having with their exams, we didn't think it was fair to do that. I mean, yeah, on the one hand, there is a certain irony that I've spent the last 8 years trying to force more practical elements into a curriculum, whereas if we'd had the old curriculum, it would have been much easier to switch online. But equally, I think we're finding some really interesting new opportunities. Certainly, some of the teamwork activities we've seen, the online environment for teams has created new dynamics that actually can be quite positive. I think we've got some work to make those adjustments, but actually I think there's a lot of positive things you can draw from ways of operating that the online world has brought about. It is undoubtedly challenging. I mean, the students really enjoy the make and build projects. They're the ones that they always, you know, the things like the climbing robot that I saw, those are always the favorite favorite projects of the students. And so thinking about how we do that in different ways. One of my colleagues is thinking about one of the teamwork, doing one of the teamwork kickoffs in Minecraft at the moment, and whether they can do a build project in Minecraft together as teams. That'd be quite interesting. So I think it's pushing innovation, and I think it will be quite interesting. I don't think everything will work. For me, I think the biggest challenge is recognizing and developing all those things that you sort of get for free in the classroom, in the physical space. I'm pretty sure we can build something that gives similar learning outcomes. I'm not so worried about that bit, but those interactions and the things, the interactions with staff and between students and all those things that you sort of happen without you knowing in the classroom by the way you form, how we make sure they're because they're incredibly valuable, how we make sure they happen online in an appropriate fashion, that I think for me is the biggest challenge.
Yeah, that is true. Okay, there's another question here. So the question asks, for engineering students, what are the most important, can you recommend any self-help resources?
We've tended to develop a lot of material internally for that. I mean, we know that students, and we do a little bit about finding external self-help. We don't necessarily specifically guide people towards it, but certainly something we added in more when we saw this inquiry-based learning really come out, not something that we'd entirely planned for, but being developed in the scenarios. So no, we don't necessarily direct people outside so much, but we do see that students, are using Coursera, LinkedIn Learning, other sorts of platforms to develop often particular skills. So one of the things we saw a lot was that, which we didn't appreciate, students, the mechanical engineering learn CAD quite early on, but many of the others don't. And yet, some of the electronic engineering students, for example, were thinking, building a system and deciding, they needed to 3D print something to hold it together. And so went off and learned a bit of CAD to design things that we didn't necessarily teach, but they were picking up these skills to do things that they felt were necessary in the project.
That's interesting. I can see that you have a lot of support from the dean, and you were having a lot of other than the support, you also have help from those who have done something similar, and you pull those people in.
Yeah, I mean, we certainly took inspiration from many places, took advice from many places. It is interesting. I mean, I think the one thing it's funny, we get people turn up from time to time saying, we love your model, we'd love to take it and use it in our institution. And my first reaction is usually, no, you don't want to do that. That's a really bad idea. Even I wouldn't do this again quite like this if I was doing it again. It was very much in the context of the time and the resources we had, so take inspiration by all means, take advice, but it only works as it does at UCL because it touches the right bits and connects to the right things, and in any other institution those will be different. And like any good engineering project, it's the constraints, it's understanding the brief, understanding the users that is vitally important. I mean, it has been commented to me, I think I did think about this very much like an engineering project, and I think actually thinking about a curriculum development project as in an engineering terms is actually quite useful. That concentration on the users. Actually the first document I wrote for staff was titled the problem brief. And we use that language through a lot of things. And then the specification came out next, and then there was a prototype document. And actually, we use that language of engineering design to sort of map out the stages of a curriculum development. And
so it's a very much problem-solving approach.
Yeah, and I think actually that meant many of the staff sort of connected with where we were. I think it's interesting. I think when you get into the education field, you get mired, as engineering colleagues will see, by the language of education. And I learned going into meetings not to use education terms, because it just you've got to address your audience, and
that is true.
Don't go talking about epistemologies. That's not that doesn't set you up well with a group of mechanical engineers necessarily.
Yeah, that is true. I can understand that. Okay, one final question. Was it difficult to get on board every department in the Faculty of Engineering?
Yes.
For the IEP? The
short answer is yes. And for very different reasons. There were some departments. I was fortunate. Probably the two departments that needed that probably had the most internal resistance had new heads of department come in, and they had been brought in with part of a remit to make these sorts of changes, and so that leadership was very important to that. Interesting, there are other departments who felt that actually, and often with very good reason, felt that they'd already done a lot of this work. They were heading in this direction, and that therefore they shouldn't be disrupted by it. And I think it comes back to that picture as every department was in a different state, was in a different position. They had different things that they had progressed on or hadn't progressed on, and so each one was a sort of separate challenge, and some more difficult than others. I think the challenge with each one was getting to that core of staff and then making sure that they were given enough authority within the departments. Again, there was strong leadership from the dean saying we are doing this, and that there wasn't really an option to completely opt out, but others were trying to water down what was going to happen and remove as much as they could.
Okay. That's great. So we have managed to learn a lot from your experience. I'm sure it's very valuable to all our audience here.
Pleasure.
I know I really appreciate what you have shared. I mean, your honest feedback about not listening to everyone. I think we can identify with that. Okay, so before we end, let's do a final Mentimeter. Can we have the Mentimeter screen, Dr. Kamaruddin? Okay, just before we end, can you please go back to the Mentimeter and share with us what have you gained most from this webinar? You have about a minute to do this. So John, let's look at this, because some people have answered the transformation, engineering. You talked about engineering, defining what engineering means, on how to improve engineering education, some ideas on how to change my teaching style. Very informative information. Experience the lesson from a world-class educator. Wow, that's a compliment to you. Learning agile innovation is difficult, but it's better. Case experiences, how to conduct multidisciplinary programs. Okay, that's something that is quite difficult to get. So let's look at the bottom what we have. Change is inevitable. Change curriculum. It's an absolutely useful class. Please do it again. Okay, so this was Okay, so they really like you. An eye-opener on how IEP can be made possible. Gain some knowledge related to education methodology, willing to adapt. Well, change is indeed difficult. So this is thought process and design, implementing change in engineering education challenges and process, making widespread change in an established research intensive university. So it's not impossible. So change is definitely not impossible now.
Yeah.
So not to be afraid. Okay. So some problems are fairly universal because we can see our problems in what you were saying.
Yeah. Yeah, I've rarely had anyone do so. I think they are absolutely universal. I think the solutions might not necessarily be, but I think the problems certainly are universal. I think there's a point there I think that I would pick up on of the one thing I would most strongly advise is that we use that statement, but having something that really is a core of what you want to achieve, and that you can keep referencing people back to of, this is why we're doing it, what we want to achieve. Because in the pressure of everything, it's easy to get diverted and go, but that having something to come back to, a clear statement of what you want to achieve and what the aims and objectives of doing it was very important. Just because often you found you needed to refocus because you'd got down into minute detail and lost sight of that bigger picture. And that was really, really useful to really understand what it is you want to do in your context and what's important to you.
So it's your ultimate aim and the core values.
Definitely.
Yeah, definitely. Thank you very much, John. I
Pleasure.
really appreciate you spending your time here. So thank you very much to all the audience. I hope you have enjoyed it. I definitely have enjoyed it. Come back to join us for another webinar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Over to you, Dr. Yana. Tak dengar. Yana, you need to unmute.
Okay, sorry. Thank you, Prof. Khairia and Prof. Chan. Thank you for watching. We really appreciate to have audiences all over the world. Hope you gain your knowledge from this sharing. I would like to remind you to fill the attendance to get an e-certificate after this. And the link will close 1 hour from now. Oops, don't move. Please stay tuned. I have an announcement here. For your information, CEE will organize the 4th CEE Webinar Series on the 2nd of July 2020 at 10 a.m. Malaysian time. The speaker will be IR Dr. Siti Hawa Hamzah, Director, Board of Engineers Malaysia, and also Prof. Dr. Khairia Muhammad Yusof, Director, Center for Engineering Education UTM. Wow, the topic is very interesting, and I think it's a quite hot topic where they will talk about preparing open book examination for engineering courses. So don't forget to save your date. Now click your calendar, click 2nd July 2020, 10 a.m. That's all for today. Don't forget to like, share, and subscribe our channel. Thank you.